In this unit, we shall study the need of communication among computers which are placed at different geographical locations. To understand network communication, we will discuss analog and digital signals, transmission speed, transmission mode and transmission media. Students, let us first discuss the term communication. The word communication comes from the Latin word communicare, which means to share different types of information, ideas and knowledge between a sender and a receiver. Communication system consists of 5 basic components named data source, transmitter, transmission medium, receiver and destination. Now, let us discuss the importance of network communication. According to A.S. Tannenbaum, a computer network is an interconnected system of autonomous computers. The computers, which are either located close to each other or installed at geographically distant places, are connected with the help of various network devices such as switch, hub, etc. These network devices and transmission media such as copper cable, OFC, that is optical fiber cable, or satellite communication are used for sharing of various resources.
This strong need for sharing of various resources led to the development of computer networks. Analog and digital signals. For communication among various parts of computers, digital communication is used, which means the signal sent from one device to other are in digital or binary form. A signal refers to a desired electrical voltage, light pattern or electromagnetic waves. Digital signal is the most appropriate format of transmitting computer data because it is a simpler technology and less expensive. Digital signals are less vulnerable to errors caused by interference and not subject to distortion. As against digital signals, the telephone lines use analog signals which are electromagnetic waves that constantly change. Analog signals are less vulnerable to the problem of attenuation. Attenuation is a gradual loss of signal strength because of distance. Therefore, analog communication has been used for long distance communication. For converting these analog signals into digital signals or vice versa, we need a device called modem.
Let us now discuss about how these signals are transmitted. Data transfer speed over a long distance is measured in bits per second, denoted as BPS, also called as bandwidth. Bandwidth refers to the amount of data that can be carried from one point to another within the given time period through a communication media. Different applications require different bandwidths. Nowadays, due to increased internet connectivity, communication speed of megabits per second, that is Mbps, and gigabits per second, Gbps, is easily available.
Now, we will discuss the different ways for transmitting data from one point to another, also called as data transmission modes. There can be 3 different transmission modes on the basis of the direction of the data transfer: simplex, half duplex and full duplex modes. A simplex mode is a connection in which the data flows only in one direction from the transmitter to the receiver. For example, from your computer to the printer or from the mouse to your computer. A half duplex system can transmit data in both directions, but only in one direction at a time. Therefore, each end of the connection transmits turn by turn. This connection makes it possible to have bidirectional communications using the full capacity of the line. A walkie-talkie operates in half duplex mode. It can only send or receive a transmission at any given time. A full duplex connection is a connection in which the data flows in both directions simultaneously. This means that the bandwidth is divided into two for each direction of data transmission. The best example of a full duplex mode is a telephone conversation between two persons in which both persons can listen and speak simultaneously. Data transmission media. The next step is to understand the meaning, functions, and types of transmission media. Transmission media is a pathway that carries the data from sender to receiver and is used to connect two or more computers in a network. We use different types of cables or waves to transmit data through electrical or electromagnetic signals. These signals can be transmitted through copper wires, optical fibers, atmosphere, water, or vacuum. The quality of the network system is dependent on its transmission media. Transmission media is broadly classified into two groups: wired or guided media and wireless or unguided media. Wired or guided media are the cables that are tangible or have physical existence and are limited by the physical geography. Wireless or unguided media are the ways of transmitting data without using any cables. These media are not bounded by physical geography. Nowadays, wireless communication is becoming popular. These two types of transmission media have further subdivisions, but let us first talk about wired transmission media, which is further classified into following categories: twisted pair, coaxial cable, and optical fiber cable. Twisted pair cables. These cables consist of copper wires which are twisted together. The twisting tends to decrease the crosstalk interference between adjacent pairs in a cable. Twisted pair can be used to transmit both the analog and the digital signals. For analog signals, amplifiers are required, whereas in the digital transmission, repeaters are needed for higher data rates. Twisted pair cables can be shielded or unshielded. Shielded twisted pair cable is made up of pair of copper wires twisted together and covered in a foil or mesh with an outer PVC jacket to prevent the electromagnetic noise and crosstalk. This technique has been used in old telephone networks. Unshielded twisted pair cable or UTP does not rely on physical shielding to block the interference. These are used in telephone systems and Ethernet networks. Ethernet is a standard protocol for LANs. UTP cable is lightweight, reliable, and inexpensive. It also reduces the problems of crosstalking. Unshielded twisted pair cable has 6 categories, which are denoted as Cat1, Cat2, etc. Cat1 or Category 1 is used to transfer voice data over telephone cable. Cat2 is a network cabling consisting of 4 UTP wires used for token ring networks and transmits up to 4 Mbps. Cat3 consists of 4 UTP wires and are used with Ethernet networks. They can transmit up to 10 Mbps. Cat4 can also be used with Ethernet networks but have higher transmission speed up to 16 Mbps. Cat5 cable consists of 4 twisted pair terminated by RJ45 connector. Cat5 is primarily used in LANs for high communication speed up to 100 Mbps. Cat5e is the most commonly used installation with greatly reduced crosstalk and handles communication speed up to 1000 Mbps. Cat6 handles crosstalk even better and can have communication speeds up to 10 Gbps. Connector. The standard connector for unshielded twisted pair cabling is an RJ45 connector. This is a plastic connector that looks like a large telephone style connector. A slot allows the RJ45 to be inserted only one way. RJ stands for registered jack, implying that the connector follows a standard borrowed from the telephone industry. Twisted pair cables have certain advantages. They are universally preferred for various industrial applications due to their flexibility. Twisting helps in using different communication lines within the same duct. They are extensively used in the media and entertainment industry. The grounded shield of wires help in the reduction of noise, and most of the standard twisted pair cables help in incorporating different types of data applications like voice, sound, video, etc. The second type of wired transmission media relates to coaxial cable. This cable consists of specially wrapped and insulated wire lines capable of transmitting data at high bandwidths. The cable consists of a central copper wire surrounded by a PVC insulation over which a sleeve of copper mesh is placed. The metal sleeve is again shielded by an outer shield of thick PVC or Teflon material. The signal is transmitted by the inner copper wire and is electrically shielded by the outer metal sleeve. Coaxial cable can be thick coaxial cable called thick net or thin coaxial cable known as thin net. It is used in a variety of applications. Various important applications include cable and DTH television transmission, which carries hundreds of TV channels, long-distance telephone transmission, short-run computer system links, and local area networks. Various types of coaxial cable are RG6, RG8, RG58, RG59, etc. The most common type of connector used with coaxial cables is the BNC connector. Different types of adapters are also available for BNC connectors like a T-connector, barrel connector, and terminator, etc. Advantages of using coaxial cable includes higher bandwidths than twisted cables, higher noise immunity, clean and crisp data transmission without distortion of signals, and lastly, several coaxial cables can be packaged in a large cable to handle over 40,000 telephone calls simultaneously. This brings us to the third and most widely used communication medium of wire transmission, that is optical fiber cables or OFC. An optical fiber is an ultra-fine glass fiber which transmits light signals rather than electric signals for data transmission. As we can see in this figure, OFC has a cylindrical shape and consists of three concentric sections, which are the core, the cladding, and the jacket. Optical fiber transmits a signal-encoded beam of light using a phenomena called total internal reflection. Total internal reflection can occur in any transparent medium that has a higher refractive index than the surrounding medium. We can see the movement of signals in an optical fiber communication system. From the source side, a converter converts electrical signals into light waves. These light waves are then transmitted over optical fiber at the receiver's end, where another converter is placed. This converter detects the light waves and converts them back into electrical signals. Optical fiber cables can transfer information at a higher speed. They are mainly used in long-distance communication. Optical fibers are commonly used in telephone connections, ultra-high-speed internet connections, TV, for example IPTV, video conferencing, illumination, for transmitting images, and for sensors and fiber lasers.
Optical fiber communication has a number of advantages, like they have greater capacity, due to which they can carry signals with higher bandwidth. They permit transmission over longer distances and require only few repeaters. They are much lighter and thinner than copper cables of same bandwidth. This means less space is needed in underground cabling ducts. These are also easy to install. Attenuation is significantly lower for optical fiber cables. Optical fiber systems are not affected by external electromagnetic fields. Fewer repeaters mean lower cost and fewer sources of error. Running cost of optical fibers is less than coaxial cables. Copper system consumes far more electrical power than optical fiber to carry the signals. Optical fibers are immune to electromagnetic interference from radio signals, lightning, etc. They can be easily routed safely through explosive or flammable atmosphere, for example, petrochemical industries.
Wireless communication. Students, having discussed the various types of wired transmission media, let us now look at the various ways in which wireless communication can take place. As you may be aware, wireless communication is a mode of information transmission without the help of any wires and cables. It is the transfer of information between two or more points that are not connected by an electrical conductor. The transmitted distance can be very short, as between a TV set and its remote control, or very long, as in radio communication. Some of the devices used for wireless communication are cordless telephones, mobiles, GPS units, Wi-Fi modem, and satellite television. Some examples of wireless communication includes the traffic control systems, infrared and ultrasonic remote control devices, cellular phones, Bluetooth, cordless telephones, satellite television, and cellular networks. Various types of wireless communication are classified on the basis of the technologies used in them: infrared wireless communication, radio wireless communication, microwave wireless communication, and satellite wireless communication. Infrared wireless communication transfers the data or information in the systems using infrared radiations. Infrared wireless is used for short and medium range communication such as television remotes and security systems. For infrared communication, there must be no obstruction between the source and destination, that is, it works in line of sight mode. Radio wireless communication uses radio waves, which are electromagnetic signals transmitted by an antenna and travels through air. As shown in the figure, a transmitter is used to transmit radio waves to a receiving antenna. To broadcast the program, radio stations are linked to the radio networks. Radio waves use different frequency segments, and an audio signal can be received by tuning into a specific frequency segment. When we wish to listen to an FM channel, all we need to do is to tune the radio to accept that particular frequency. Radio broadcasting can also be done via cable FM, the internet, and satellites. A radio broadcast can send the data to a very long distance with very high speed. Another important type of wireless communication media is microwave communication. Microwave communication involves the transfer of data through the microwaves, which primarily use radio waves. Microwaves are used to transmit messages between ground-based stations and satellite communication systems through antennas. For two-way communication to take place, two different frequencies are used. Microwave communication works on line of sight mode. The main drawback of microwave communication is that they are affected by bad weather, especially rain. In order to overcome the problems of line of sight and power amplification of weak signals, repeaters are used at an interval of about 25 to 30 kilometers of distance between the transmitting and receiving stations. Satellite communication. Microwave communication requires several repeaters for long distance transmission, leading to increased cost of data transmission between 2 points. This problem is overcome by using satellites. In satellite wireless communication, an artificial satellite is used as a communication transmitter in the orbit. Since a satellite is positioned in a geosynchronous orbit, it is stationary relative to the Earth and stays over the same point on the ground. This allows a ground station to aim its antenna at a fixed point in the sky. It is similar to the radio relay station above the Earth to receive, amplify, and redirect the analog and digital signals carried on a specific radio frequency. Data is passed through a satellite using a transponder, which is a signal path. The satellite wireless communication uses C-band and Ku band of electromagnetic spectrum. In the near future, use of a much higher frequency band known as Ka band is expected to increase.
Students, let us talk about the advantages of satellite communication. Satellite communication has a number of advantages, like it is visible from a very large area and can be easily used for data transmission between any two randomly situated points. Apart from this, data transmission cost of satellite communication are very low, as it is independent of the distance between 2 points as long as the 2 points are within the area covered by the satellite. A satellite having many transponders has enormous data communication capability. Satellite wireless communication suffers from some limitations also. The initial cost of placing a satellite into its orbit is very high. There is a difference in sending and receiving time of information. Satellite communication requires special security measures in order to prevent unauthorized tampering of the information.
In this module, we have discussed various aspects of network communication such as transmission mode, transmission media, and their applications into various fields. Various data transmission modes are named as simplex, half duplex, and full duplex. These are selected as per requirement in communication network. The communication media are mainly of two types: wired communication and wireless communication. Wired transmission media includes twisted pair cables, coaxial cables, and optical fiber, and wireless transmission media incorporates infrared, radio waves, microwave, and satellite communication.